All right, so we were working in section 6.1 the other day. Let's take a look at these problems. Find the 6 trigonometric function values of the specified angle. All right, so we're dealing with this angle here. So we want to find sine of theta. How do I find sine of theta? Opposite over hypotenuse. Okay, so which side, if this is theta, which side is the opposite side? 6. And which one's the hypotenuse?
13 over 2.
13 over 2. So I'm going to have 6 over 13 over 2. I'm going to flip and multiply, and I'm going to write that as 12/13. Thank you. How about cosine of theta? It would be adjacent, which is 5/2 over the hypotenuse. So that's going to be 5/2 over 13/2. Again, I would flip and multiply. That turns out to be 5/13. Tangent of theta. How do you find tangent? Tangent is opposite, which is 6, over adjacent, which is 5/2. 6 over 5/2. Again, I take the 5/2, I flip and multiply. Turns out to be 12/5. So there's the first 3. How do I find the other 3? Just flip them. So you would tell me that cosecant theta is what? You flip sine, that's 13 over 12. And secant of theta, 13 over 5. And cotangent of theta, 5/12. All right, how about number 2? Given that sine of beta is 2 square roots of 2 over 3, cosine of beta is 1/3, and tangent of beta is 2 over the square root of 2, find cosecant, secant, and cotangent of beta. What would you do there? Yeah, all you really got to do is flip them, isn't it? So our answer would be cosecant of beta would be what? 3 over 2 square root of 2. Are we okay with leaving the square root on bottom? Personally, I'm okay with it. But if you're doing your extra credit on my lab's not going to take it.
I was doing it and it wasn't.
Yeah,
nothing,
same here.
like,
Oh, you didn't have to rationalize? Oh, good. Then I was wrong. So I guess you can leave it just like that. All right, so we'll leave it just like that. Good. I don't like rationalizing. Secant of beta is 3, because you would take 1/3 and flip it. That's 3 over 1. And finally, cotangent of beta. Bless you. 1 over 2 square roots of 2. And there's a name for what we just did. Those are called the reciprocal identities. What do we mean by reciprocal identities? What's the word reciprocal mean? Not opposite. Opposite means put a minus sign in front of it. What does reciprocal mean? Flip. Reciprocal simply means flip. So if I want to find cosecant, I simply flip the sign, and that's called the reciprocal identity. If I want to find the secant, I simply flip the cosine, reciprocal. Okay, given that sine of, anybody know which Greek letter that one is? I think that one's gamma. I think. Might be gamma. I don't know. Given that sine of that thing is 10 over 11, where that thing is an acute angle, find the other 5 trigonometric function values. What are you going to do there? I think it would be very helpful to draw a triangle. I agree. I'm going to draw a right triangle. Here's my angle, like so. And then how would I label this triangle?
You have to use that. Well, sine is opposite over hypotenuse.
Sine is opposite over hypotenuse.
So the opposite would be 10.
So the opposite would be 10, and the hypotenuse would be 11.
Then you can use the Pythagorean theorem.
And then I can use the Pythagorean theorem to find the other one. So a squared plus b squared is c squared. That's going to be 10 squared plus b squared is 11 squared. So b squared is 11 squared is 121. 10 squared is 100. So we're going to have 121 minus 100, that's 21. Which means b is square root of 21. And that's the hard part. And that wasn't really very difficult, I don't think. Once you have that, you can easily find the other ones. So now we know cosine of that angle is square root of 21 over 11. And tangent of that angle is 10 over square root of 21. And then we can find the other three just by doing our flipping trick, which means cosecant of the angle is 11 tenths. Secant of the angle is 11 over the square root of 21. And finally, cotangent of the angle is square root of 21 over 10. Questions on that? All right, problem 4. I'm not going to do problem 4. Why not? Because I'm lazy? Because what are you supposed to have done with those? You're supposed to have memorized those by now. I absolutely guarantee you better have them memorized by Monday. Why should you better have them memorized by Monday? Because we will be having a quiz on Monday on section 6.1. That's correct. So you absolutely better know these by Monday. I promise you that filling out that chart is going to be on the quiz. Absolutely, positively guaranteed. All right, number 5. A civil engineer must determine the height of the tree shown in the figure. The given angle was measured with a clinometer. What's a clinometer? Anybody ever seen a clinometer before? No? You ever been driving along the road and see a crew out there with a thing on a tripod and they got a little looking glass that they're looking through? It's what a surveyor uses. That's called a clinometer. That's correct. And what's it do? You can use it to make a straight line. It also very accurately measures angles. So you can have the clinometer set up here, sight through it, look to the top of the tree, and then you can look and you can read that angle off. So that's what a clinometer can do. Okay, so how does that help us? Knowing that this angle is 32 degrees, and knowing that we're 76 meters away from the tree, how does that help us find the height of the tree? Look. We have a triangle here, that's right. This is a nice right triangle.
We assume it's a right triangle.
We're going to assume the tree is growing straight up and down, so we're going to assume it's a right triangle. Yep. So there's our 90-degree angle right there. Then what? Now how am I going to figure out this height over here?
Add those two numbers together. I think I love the other angle.
I could find this angle up here, that's true, but I don't think I need it. What I have here is I have the angle. This would be the opposite, and this would be adjacent. So which trig function uses opposite and adjacent? No, sine uses opposite and hypotenuse. Tangent uses opposite and adjacent. So I think tangent of 32 degrees would have to be the opposite over 76 meters. So how am I going to find the height? solve. Simply multiply by 76. So h is 76 tangent 32 degrees. And I'm going to use my calculator.
Wouldn't that be an O?
Wouldn't what be an O?
H?
Well, they call it h for height, though.
Oh.
So I use, yeah, that's a little confusing. That h stands for height and not for hypotenuse. Yeah, that's a good question. All right. Now, when you go to use your calculator, it's hard to see. First thing you need to do is make sure that your calculator is in degrees mode. By default, they're usually in radians. So you're going to hit this mode button and go down, and you'll notice mine is in radians. Make sure it's in degrees. It's hard to see on the screen there. There it is. Make sure you got that black box on degrees, otherwise you're not going to get the right answer. 76 tangent 32. Calculator tells me it's about 47.5 meters tall. Questions on that? All right, what's on the back side? All right, so here's something we didn't get to on Wednesday. Sometimes angles are written like you see in part 7. Sometimes they're written as decimals. Sometimes angles are written using what are called degrees, minutes, and seconds. And it's helpful to be able to convert between the two. Anybody know how to take 52 degrees 15 minutes and convert it to decimal?
Put 15 over 60.
Why do you put 15 over 60?
Because I got
Well, how many minutes are there in a degree?
yeah.
Yeah, it's kind of like just doing it on a clock. If I told you 52 hours and 15 minutes, how would you convert that to just being hours? Well, 15 minutes, you would take 15 minutes and divide it by 60 to convert it into hours. So we're going to take, this is going to be 52 degrees plus 15 over 60. And we should get 52 point, I might take my calculator and do 15 over 60, and it's a quarter. So that's 52 and a quarter degrees.
Is that a semicolon?
No, I wrote in the wrong spot there. That's supposed to be just a decimal point, 52.25. And that's, ignore that dot up there, I wrote in the wrong spot. I started to write the degree symbol and realized I didn't want it there. All right, now this one has 68 degrees, 2 seconds. Double hash is seconds. How do I take seconds and convert them into decimal? I divide by the number of seconds in an hour. How many seconds in an hour? 30. Well, how many minutes in an hour? 60. And how many seconds in a minute? 60. So it's going to be 60 times 60. What's 60 times 60? 3,600. So I'm going to have 68 plus 2 over 3,600. 68 plus 2 over 3,600. My calculator tells me that's 68.0005. 555 repeats over and over again, so I'm just going to put a 5 with a bar over it. And then how about the last one? How would I take 19 degrees, 47 minutes, 23 seconds, and convert that to a decimal? I can do them both at once, actually. So I can just take the 19 degrees plus, how do I convert the minutes? Divide by 60, so I'm going to take 47 over 60. Plus, how do I change the seconds? 23 over 3,600. I'm going to grab my calculator. 19 plus 47 over 60 plus 23 over 3,600 is not very nice. 19.78972, and then it looks like the 2 repeats over and over and over again. I put a bar over the 2. Questions on that? Okay, how do I go the other way? What if I have a decimal and I want to convert it to degrees, minutes, seconds?
You just times it by 60.
Times it by 60? Okay, so I'm going to take 0.84 and multiply by 60. If I do that, 0.84 multiplied by 60 gives me 50.4. So that would be 50.4 minutes. Usually when we write degrees, minutes, seconds, we just want minutes. We don't want 50.4 minutes. So what am I going to do with that 0.4? I'm going to convert that to seconds. How do I take 0.4 minutes and convert them to seconds? Not divide, rather multiply. So I'm going to take the 0.4 and multiply it by 60 again. So 0.4 times 60.
Why wouldn't you times it by 3600?
Because remember, I already took this whole number and I multiplied it by 60 once. So this is in minutes. I'm now converting 0.4 minutes into seconds. So how many seconds in a minute? Just 60. We already did the 60 once. All right, so our answer would be 67 degrees, 50 minutes, 24 seconds. So basically you multiply by 60, and then you take the decimal portion and you multiply it by 60 again. Do it twice. All right, so this one, 0.253 degrees. I would just take the 0.253 and multiply it by 60. That tells me it's 15.18 minutes. But again, usually we don't write decimal portions of minutes. So I'm going to take that 0.18 and do what with it? Multiply by 60 again. So 0.18 times 60 is 10.8. So now we're kind of stuck. So we're going to have to write this as 15 minutes, 10.8 seconds. Sometimes your seconds do have decimals in them. Not a whole lot you can do. I mean, we could multiply by 60 again, but do we have a name for that? Not that I'm aware of. When you take when you take a second and split it into 60 units, I don't know the name for that, so we'll leave it. All right. Find the trig function. Tangent of 63 degrees, 48 minutes. You're just going to type this into your calculator. But how do you type in degrees and minutes into your calculator? Anybody know?
Angle.
You use the angle. So you're going to type in tangent. And then you're going to type in 63. And then there's the angle button, which is right here on the same button as apps. So you're going to go second angle. There's degrees. 48. Second angle. Minutes. You hit enter, and it tells you the answer is, rounding to 4 decimal places, 2.0323. What if you needed seconds? I don't see seconds under that angle button. I see degrees, I see minutes.
You have to convert it.
Nope.
Alpha plus.
It's on the alpha plus way down here. Hard to see on my screen there, but there's a minutes symbol right there. Or seconds, I mean. If you need seconds, it's on the plus button. Secant of 35.28 degrees. My calculator doesn't have a secant button.
You gotta slow down.
Seconds.
Go ahead.
It's 2 seconds.
Use second cosine? No, that uses something very different. That symbol is cosine inverse. We'll talk about that eventually. That's a very different symbol. That's not secant. So how do you get secant on the calculator?
1 divided by cosine.
You use the reciprocal function. So to do secant of 35.28, I do 1 divided by cosine of 35.28. And I hit enter. 1.2250 rounding to 4 decimal places. I'm going to skip number 9 and I'm going to go to number 10 for a minute. We'll come back to number 9. It wants to know the angle theta so that the sine of theta equals a half. What is it?
30.
30? 30 degrees? 30 degrees. Why 30 degrees? Because we've memorized that chart that came from that 30, 60, 90 triangle, and we know that sine of 30 degrees is a half. So the correct answer is 30 degrees. So we're kind of going backward. In that chart, I gave you the angle, I gave you 30 degrees, and we determined that sine of 30 degrees was a half. Now we're going backward. I'm giving you the 1/2. You're telling me the angle. How about this one? Secant of theta is square root of 2. I heard 45, I heard 60. Might as well throw 30 out there because it's the only other possible answer. One of those is right. 60? Well, let me ask you this. If the secant of theta is square root of 2, what would cosine of theta have to be? 1 over root 2. And typically we rationalize that and we write it as root 2 over 2. So cosine of what angle is root 2 over 2? 45 degrees. 45 degrees should be the right answer. Okay, back up to number 9 now. It's giving me tangent of theta is some number. That's not one of the numbers that I recognize from that chart. So how am I going to find theta?
You hit the second.
That's what that button does. So let's try this one, for example. Sine of theta is a half. If I want to know angle, that's what this button does. That button we talked about a minute ago, that sine inverse button, I would type in sine inverse of a half, and that tells me 30 degrees. That's what the sine inverse button does. The sine inverse gives you the angle back. So if I want to know the angle here, I want to get rid of a tangent. To get rid of tangent, I use a tangent inverse. So my answer would be tangent inverse of 2.032. So that angle would be, to the nearest tenth of a degree, 63.8. degrees. Now for cosecant, I've kind of got the same problem. I don't have a cosecant button on my calculator. So what am I going to do?
1 divided by second.
I'm going to first write this as sine of theta is 1 divided by 1.147. And then to get the angle theta all by itself, I'm going to use the sine inverse. So my answer should be sine inverse of 1 divided by 1.147. 60.7 degrees. Questions on that? Questions on how that works, especially with the cosecant one? That was a little bit confusing.
Wait, I'm sorry, you just put in on your calculator?
Yep, in my calculator I typed in sine inverse of 1 over 1.147.
Which is
which is the angle.
the 1 over 1.47 is if it was not
Right. I don't have a cosecant button, so before I can do this, I have to convert it to sine. I only have sine, cosine, and tangent buttons on my calculator. So I always have to convert everything to those. All right, the last thing. Something we haven't quite talked about yet, the cofunction identities. We know the reciprocal identities. So this last one is asking sine of 64 degrees is the same as 1 over sine of what? I'm sorry, 1 over something of 64. What's the reciprocal of sine?
Cosine?
Nope.
Or, I'm sorry, the cofunction.
Cofunction would be, so this one would be cosecant for the reciprocal. That one we've talked about. And how about this one? If I have secant on top, what am I going to have on bottom? Cosine. Okay, so those are the reciprocal ones. These ones down on bottom. What we haven't talked about yet is cofunction. Anybody know what cofunction means? Well, let me draw a triangle for you. And here's my angle theta. And we'll call this, we'll make it easy, we'll make it a 3, 4, 5 right triangle. So in that triangle, what's the sine of theta? Opposite over hypotenuse, 3/5. What if I want to look at that angle up there? First off, how big is that angle? Big enough? Okay. Can you be more specific? Equal to the other angle? Not quite. To be equal to the other angle, this would have to be length 3 and that one would have to be length 3. It would have to be a isosceles triangle.
Less. Bigger.
It's bigger, that's true. Let me ask you a question. How big is this angle right here?
90.
This is 90 degrees. How many degrees in all the angles added together? 180. So if this one's 90, then these two combined have to be 90. So if this one is theta, how much is left over for that one? 90 minus theta, the rest of it, correct? So this angle right here is 90 minus theta. That's called there's a name for that? Two angles that add up to 90 degrees?
Complement.
Those are called complementary angles. Very good, complementary angles. If I look at this angle up here and I ask you to find the cosine of that angle, what's the cosine of this angle up here? It's adjacent to that angle, which is 3 over hypotenuse. It would be 3/5. Those are known as the cofunctions. The sine of one angle in the triangle is the same as the cosine of the other angle in the triangle. That's called cofunctions. So, sine of 64 degrees is exactly the same as cosine of 26 degrees, because 64 plus 26 add up to 90.
So does that mean that tangent's not really in it at all in that situation?
Yes, tangent's in it. So if this angle, if I do tangent, that would be 3 over 4. For this angle, what would I do to get 3 over 4 again? Cotangent. So tangent and cotangent are cofunctions, which is a little weird because sine and cosine are cofunctions. Tangent and cotangent are cofunctions. So those would go together. All right, so how about this one? Secant of 13 degrees is exactly the same as cosecant of what? 77. Why 77? Because they add up to 90. Those are the complementary angles. 77 degrees. Questions on that? All right, we got just a couple minutes left. We're going to start section 6.2 just a little bit, and then we'll get more to section 6.2 on Monday. Section 6.2, we're going to talk about solving right triangles. What does that mean, to say solve a right triangle?
Find the sides and angles.
It means find everything that's missing. Correct. So we'll draw a triangle here. This will be a right angle. Somebody give me a reasonable number. What's that angle right there?
32.
That looks like it's about 32 degrees. And then pick a side.
15.
The opposite is 15. Okay, so when I say solve that triangle, what I mean is find all the missing pieces. So I want to know this angle, I want to know the length of the hypotenuse, and I want to know the length of that side. So I'm going to call this side A, and I'll call this side C. So B is 15, and that angle is 32 degrees. How are you going to do that? The angle's easy to find, isn't it? The angle has to be the complementary angle. So I'll call that angle theta. So theta has to be 90 degrees minus 32 degrees, which is 58 degrees. So the angle in this case is easy to find. The angle is 58 degrees. All right. Let's go for A next. How would you find A? The law of sines. We don't know the law of sines yet. Although that would work. We'll get to law of sines eventually. It's easier than that. Law of sines is more complicated than what we really need here. Well, let's see. I know this angle, right? And I know opposite. And I'm trying to figure out something about adjacent. So what function has the angle, opposite, and adjacent? Tangent. So tangent of 32 degrees has to be what? 15 over A. So you're going to kind of look at what you have, and you look at what you have, and that's going to tell you which trig function you should use. Because we have opposite and we want adjacent, we use tangent. How do you get the A all by itself? Multiply both sides by A. So A tangent 32 degrees equals 15. Divide. A is 15 divided by tangent 32 degrees. And I'll grab my calculator, see what that is. 15 divided by tangent 32 degrees is, we'll call it 24. I got 24.005. We'll just go ahead and we'll call it 24.
Do you have to put the degree in there, or do you just put
In my calculator? My calculator is in degrees mode, so I do not have to put the degree symbol. The calculator assumes that's 32 degrees. All right, so the only thing left is C. How would you find C? Pythagorean theorem. The Pythagorean theorem would work, but it's a bad idea. Why is it a bad idea? 24 is not exact. What is 24? I rounded it off, didn't I? Whenever you can, you want to avoid using numbers that you rounded off. Why? Round off error tends to grow. And so since this one isn't exact, if I use it to find the next value, my answer is going to be off by more. Generally, round off error tends to get bigger and bigger. So sometimes you can't avoid it. Sometimes you have to use numbers that you found. If you can avoid it, do so. And I think we can avoid it by saying, Here's my angle 32. That was given information. This is opposite, and this is hypotenuse. So what uses opposite and hypotenuse? Sine. So it would be better to do sine of 32 degrees is 15 over c and solve it that way. Is using the Pythagorean theorem going to give you a big error? Not for a problem like this. Reality, it's going to be awful close. It's going to be very good. But that's a general rule of thumb. Avoid using rounded off numbers whenever you can. It's always best to use given information. And here would be even worse. What if you made a mistake in finding this number and this number was wrong? And if you use this number, then you're absolutely guaranteed the next number is going to be wrong too. So it's always best to use given information, always best to avoid rounded off numbers. All right, well, this is the same as c equals 15 over sine 32 degrees. So I grab my calculator. 15 divided by sine of 32 degrees. Calculator says 28.3. I'll round it off to one decimal place. I guess is good. Questions on that? All right, one more problem. We'll be done for today. Here's another triangle. It's a right triangle. This side has length 6, and this one has length 10. So I want you to find that side C. I want this angle, I'll call this one alpha. And I want that angle, I'll call that one beta. Alpha and beta seem to go together nicely. Well, what do you want to do first?
Find the other side.
Find the other side. I think this time finding the other side is a pretty good idea. What are you going to do to find the other side? Pythagorean theorem this time. I think it's a good idea. So c squared is 6 squared plus 10 squared. So c squared is 136. C would be square root of 136. All right, that was the easy one. What's next? Sine. Sine of what? Sine of alpha would be what? 6 over c. Again, that's okay. But again, this c is a number that I figured out. I'd rather avoid using it if I can. So instead of using sine, let's use something else. Let's use tangent, because tangent is opposite over adjacent, and that uses numbers that were given to me. Again, that's always best. It's always best to use numbers that are given to you when you can. So I would use tangent of alpha is 6 over 10. How am I going to figure out alpha? I use that tan inverse button on my calculator. All right, so it's tan inverse of 6 over 10. 10, not 20. Let's call it, well, rounding off to the nearest tenth would be 31 degrees. Alpha is 31 degrees. Finally, how would I find beta?
Just subtract 90 and 31 from 80.
Okay. Again, I could do 90 minus 31, and that should be good.
Yeah.
Again, be careful though, because you're using a number you figured out. So are you really confident that answer is correct? Then you're okay. Otherwise, what I would probably do is I would do tangent of beta is 10 over 6. And let's just check to see if we get the same answers. I should get, what should I get? 59 degrees. Let's make sure I get that. Tangent inverse of 10 over 6. And I do get 59 degrees, so they do give you the same answer. But again, be cautious using any number that you figured out. It's always best to use given.